In this lesson, we're going to take a look at current, voltage, resistance, and Ohm's law, which sounds like a lot, but remember, voltage is simply a measure of electric potential energy per charge. So this is energy per charge, and what we're really talking about here is this is what pushes charge through a circuit. Then we have current. Current is the rate at which charge flows. So essentially, more current means more charge is moving, or charge is moving faster. So the rate at which charge flows. And then finally we have resistance, and resistance opposes current. And so current doesn't get to flow unimpeded, and different things can have more or less resistance. Usually heating things up causes their resistance to go up because there's more random motion, so the charge can't all flow in one direction. Now, all three of these things have their own units and symbols. Voltage is measured in volts, and it gets the symbol V. So that one's pretty straightforward. Current, on the other hand, is measured in amps. Amps are abbreviated capital A, and it gets the symbol I. It's not my fault, I don't make the rules. And then resistance is measured in ohms. In ohm gets the symbol omega. It looks like an upside down horseshoe. And it is abbreviated with an R. So if we have a circuit has a complete path for electricity to flow, and it's got some energy source, some voltage source that's actually pushing these charges around. You might see me write something like this. This is the symbol for a battery or a direct current voltage source. Now I say direct current because remember, current can flow in one direction only, like what a battery does, or it can flow back and forth like what your household current does. And so direct current flows in only one direction. We call that DC. Alternating current reverses direction. It's not steady state. We call that AC, alternating current. Now, here is a small circuit, so we've got a battery. The longer plate is the positive side, and we'll put a light bulb on that, and the light bulb is creatively a little loop with a glass ball around it, and then we're going to go ahead and close that path up. So these straight lines represent wires. A wire is assumed to have no resistance at all, and so charge can flow through that wire, goes through this light bulb. That's a load. That light bulb is actually going to have some resistance to it, and then that current continues around, and so we have this thing which increases the potential energy of the charge, this power source, and then we have this thing that uses that energy and it produces heat and light. Okay, and so in the parts of this circuit we have our voltage source, and then we have some resistance here. Now what happens if I add another light bulb in the middle of this thing? Well, that makes another choke point, more resistance, and doesn't change how much energy this thing can supply, but it does prevent all of that current from moving as easily. And so what we have is Ohm's law, which says V, voltage, is equal to I times R, but really what that tells us is if we have a fixed voltage thing like a battery, increasing the resistance makes the current go down. And so voltage supplies the push to make the current go, but resistance opposes that, and so if I increase resistance, I'm going to decrease current. Similarly, if I decrease resistance, I can actually have a whole bunch of current flow. So this would be a short circuit. It's called that because there's no steps in the way, there's no resistance, and so essentially I have this voltage here, and then current can flow through there unimpeded, and so you get really, really high current. High current's bad because it increases the temperature of the wire around it a lot, to the point where you can start melting things or catching them on fire. And so this would be a high current because there's not any resistance to it. This would be a lower current because there is resistance. And so Ohm's law is pretty straightforward. It kind of makes sense. If we have this much energy to do work and we have this thing getting in the way, we're going to have less current flowing.